Thank you. Thank you. Okay, so we should have our responses in. Currently I have 18 of 26, I think it says 18. Again, I have 16 of 26, 3 are working on it. Guys, we're 5 minutes into class, it's one problem. This is a part of your grade in my class. At the end of every week, I go in and I check to see who completed the bell ringers for that week. And if you didn't complete a bell ringer for a day, you lose a point on your active collaboration. Point blank period. You don't have to have a correct answer. You got to try though. You have a small group that I can hear lots of conversations about football, but I don't hear any mathematical conversations to help each other grow and learn. Active collaboration means we are actively talking about the math. We are actively trying to help each other grow and learn. We don't have to be experts at this yet, but we do need to be trying to grow and learn. That's it. Now, let's talk through this. I see 3 up here. I see a 9x minus 6, 5x minus 6. I assume this 9x times negative 6. Guys, be careful. If you hit the negative symbol next to the decimal, that's a negative, not minus. Notice minus is next to the plus, right, on the right-hand side in white. Okay?
Oh, what's the negative symbol here?
Say again.
Oh.
You see that difference now?
Yeah.
So we gotta be careful about that. That negative is in black next to the decimal. The minus is next to the plus in white. Okay, so I'm seeing some answers here that are kind of similar, but kind of all over the place. We're not uniformly getting this correct. So let's have a discussion and make notes next to your original work. Don't erase your original work. Make a note of where it went wrong so that you can improve for the future. I am also going to cover one extra thing about distribution that I want you to be aware of. I think it will help some of us understand distribution a little bit better. Okay? So I'm going to look right here. I'm going to show you, because I walked around and I saw some people's work, and I'm going to show you the most common mistake that I saw. And if you made this mistake, don't feel bad about it. Learn from it and grow. That's a mistake. Anybody know what the mistake was? I want you to notice, this isn't necessarily the only way to do this problem, or simplify this expression, but I do want you to notice, you see how many terms are inside of these parentheses? 3 of them. If you have 3 terms inside of the parentheses, you have to distribute to all 3 of them. So 3 times x is 3x. 3 times negative 2 is negative 6, but we didn't distribute here. So that's wrong. Distribute all the way through. So I'm going to write incorrect. INC for incorrect. Distribute all the way. I would make notes about what are mistakes that people are making so that you can learn from them. Okay? Here's a second one that I saw by actually several people. In fact, if you got 5x minus 6, this is my guess what you did. You probably distributed. You may not have shown this, but then you did 3x minus 6 plus 5x. Actually, I now no longer know how we got 5x as the final answer. But I did see people write this 5x here.
The first one would have been 5x, 3x minus 6 plus 2x.
Yeah, notice that 3 times 2x is 6x. Oh, you're saying that one. You're right. So if you forgot to distribute all together, you got the 5x. Notice, right? So what happened here that someone made a mistake on? They added instead of multiplied, right? Okay. Now, there's 2 things to be aware of. One correct way is that you could have distributed all the way through. Since that's what I saw a lot of people doing, let's go ahead and do it. 3x minus 6 plus 6x yields what? 9x minus 6. That was a correct distribution all the way through and would have gotten you to the correct answer. Okay? But there is a second way to have done this problem. Does anyone know a second way to do this? Could we add our like terms first and then distribute? I've heard a lot of us say that we're supposed to do parentheses first. And a lot of times people think that means to distribute. That's not what it means to do the parentheses first. The reason why parentheses exist is this. What operation is happening between the 3 and the parentheses? Multiplication. What happens first? Multiplication or addition? But what if you need to do the addition first? That's why we have parentheses, to group them together to say, hey, you're actually supposed to add before you multiply. That's the point of those parentheses, right? Parentheses group together what I call weaker operations, right? Multiplication and division are stronger than addition and subtraction, right? So I used to create a little thing like this. So addition and subtraction, you repeatedly add, and what operation do you get?
Multiplication.
Multiplication. That is not 3. There we go. If you repeatedly subtract, do you know what you get?
Division.
Division. If you repeatedly multiply, anyone know what you get?
Repeated addition.
But remember, repeated addition was multiplication. So does anyone know how I could rewrite this?
Exponent.
3 to the 4th power.
So what is repeated multiplication? And I will say it's a what? It's an exponent, but it's not just any old exponent. It's a positive exponent. I bring that up because any guesses what repeated division would give us?
Negative.
A negative exponent. So you may have not seen this before, you probably haven't, but 3 raised to the negative 2, that negative exponent is telling me to what?
Divide.
To divide. That's literally just 1 divided by 2 3's. Right? Just like 3 squared would be 3 times 3. 3 to the negative 2 is 1 divided by 3 divided by 3. You don't have to know that, I'm just pointing that out to make sense out of this. And so at the top of all of this is not an operation, but it's grouping, it's parentheses. Because here's the thing, multiplication is supposed to happen before addition or subtraction. But what if I need to add first? Well, then I need to group things together to indicate that. Okay, so grouping 1x plus how many x's? 2 x's is, so I have 3x minus 2. Now I can distribute
9x.
Thank you, 9x
6.
minus 6. Same answer both ways, right? Yes, Maddie.
Like, how does it have that, like, you still put the 3 the part of the 4?
Well, notice I didn't distribute yet, right? So what I actually did was I looked inside of the parentheses at my like terms. And so x plus 2x, that's this 3x. I haven't multiplied by 3 yet. So the 3 is still outside because I haven't distributed. So I have 3x minus 2, and now I'm going to distribute that 3. Okay? So that's alternate ways to do this. Now, I've been thinking, if y'all remember, Joey had a really good question or brought up the other day that you're not comfortable with distribution, right? And I've been thinking about how I might explain this for anyone else who is uncomfortable with distribution. And I want us to look at this, all right? If I have 3 parentheses 3x minus 2, we're used to just distributing. Some of us are. But I will point this out. What is this multiplication right here?
Exponent.
Well, remember, repeated multiplication is the exponent, right? But multiplication is that repeated addition. Simple multiplication is repeated addition. So instead of writing it this way, I could do 3x minus 2 plus 3x minus 2. How many times would I add the 3x minus 2? 3 times. That's what we really mean when we say 3 times 3x minus 2. I'm saying that I am repeatedly adding those 3x minus 2's. Don't ever forget that multiplication is repeated addition. So notice 3x plus 3x plus 3x, what is that?
9.
That is 9x. Now, I would also point out to help understand distribution, that means it's also 3 times 3x, isn't it? If I have negative 2 plus negative 2 plus negative 2, that's plus 3 times negative 2. So notice, Joey, and for anyone else who struggled with that, what we're noting is, okay, I'm repeatedly adding 3x 3 times. So that's also 3 times 3x. That's what we mean when we distribute 3 times that 3x. Right? I've got 3 3x's. I've got 3 negative 2s, so I'm adding 3 times negative 2. I've got 3 negative 2s being added. Does that help make a little bit of sense?
A little bit.
A little bit? Okay. But notice 3 times 3x is 9x. 3 times negative 2 is negative 6 or minus 6. What I'll point out is this, and what I want to emphasize is this. If you're uncomfortable with distribution, could you rewrite that multiplication as just repeated addition and add your like terms?
Probably could.
Right.
Because that's the part I always get confused with, because like I know PEMDAS, parentheses comes first. It's like I just always add the parentheses first.
Right. But remember, like once I get to here, are there any more like terms? No. So I can't add those anymore, but I could rewrite this multiplication as repeated addition. Does that make sense? Somewhat. So we'll get more practice with it, but that is something I want you to notice. If you are struggling with that, don't forget that you can always rewrite multiplication as repeated addition. And that will help. Okay? What are your questions before we continue? Okay? I'm going to do a quick poll question. Just because I want to see if I need to do something different for y'all. Here we go.
Well, you can add that word with this one. Hey!
Okay, so I'm just sending it out just so it's a nice little anonymous thing. Alright, I'm just asking, I'm just getting you to agree or disagree that you feel like, either you feel like you're getting better or not at simplifying expressions, okay? That, again, please note, that doesn't mean you have to have perfected it. I just want to know if this is helping you get better at simplifying expressions. Alright? I've got 23 of 27. I need 4 more. Come on. There we go, 24. 25. I need 2 more to respond. Going in 3, 2, 1. What? Huh? Okay. Alright. 2 people have not responded. Unfortunate for y'all. Alright. So, yeah, let's get started. Only one thing on the agenda today after that bell ringer, and it's to work on data analysis. Why is that? I'll have to fix that later. Because it looks like I might have to restart it. Okay, I'll fix it. Okay, but we're going to get started with data analysis. Please remember, these are the foci, the focal points of what we've been doing so far. Is we want to be able to identify statistical versus non-statistical questions. What makes a question statistical? Not ability to fit in categories. That's categorical. Variability. Remember, if you expect variability in responses. No, I'm trying to do this whole thing of like teaching, and some of these conversations don't have anything to do with teaching or with learning. If you expect variability, then it's going to be a statistical question. What makes data numerical?
Numbers that can be measured.
Numbers that can be measured and numbers that can be average. Remember, we took a lot of time yesterday on mean. If you were not here yesterday, I have already uploaded and posted the video from yesterday onto YouTube. Literally, all you have to do is Google my name, Nathan Kinney, It will be probably the first one that pops up because not everybody watches them, but I have them there to support my students in being successful, and I have a lot of videos. I also have a playlist specifically for this class on there, so you can go to the channel that I have set up, and I think it's Fall 2022 Mr. Kenny's Geometry with Data Analysis or something like that. But it says geometry in there. It's easy to find, okay? I also sent it in the newsletter that I sent to your parents last night, so you can all get it that way. Yes,
I
Joe?
don't think my mom got it, because she was asking me last night about it.
If she was asking you about the newsletter, that probably means she got it. That's why she was asking you. Because how else would she know about the newsletter?
She didn't know, she was asking, I mean, she knew you had about the YouTube channel, but that's really all she knew about. She was asking like how to act, how to see it and whatnot.
Like how to get to the YouTube channel?
Yeah.
So she probably got an email from me last night. Excuse me. I need y'all to focus. Stop getting distracted. Focus on your education. I sent out a newsletter, and in that newsletter, I have an email address on the second page that can direct you to the YouTube channel. Okay? But again, if you just search my name, it's there. You just have to find the right playlist. Okay? So, oh yeah, numerical versus categorical. Can someone please open the door, Kyla? Thank you. And creating using survey questions. But we finally got into this more about distributions yesterday. By the way, I do want to point this out. You know how we spent probably like 3 or 4 days so far on learning about statistical and non-statistical questions and categorical versus numerical data and all that kind of stuff? You should probably expect an understanding check. It's kind of like a quiz, but it's a little bit different on Monday on all the things from that lesson. How to create survey questions, stuff like that. I'm just giving you a heads up. So what do y'all need to probably do this weekend? At least a little bit. Study, right? Okay. So again, those videos are on YouTube. The resources are on Schoology. But take a little bit of time. Make sure you know what it means to be to have a statistical question. Know what it means to have numerical versus categorical data. Okay, we started on this yesterday. Get the lead out, and we analyzed the data collected using only the table. What were the? We talked about the 4 different features that we should talk about in general when it comes to numerical data, didn't we? So mean, median, and mode were a measure of something. It starts with a C. Did we not talk about center? Measure of center. So we just talked about mean, median, mode. Do you remember that word?
Like frequency and the other ones right
Yeah, we talked about frequency. Mode is how frequent that number shows up. The mode is the most frequently observed data. The median was what?
50%.
The one in the middle. So what percent is below that point? 50%. And what percent is above? 50%. Right. The idea of median is it separates the bottom 50% from the top 50%. Jamalin, you okay over there? Looks like you're trying to about to go to sleep for a second. You good? Okay. And then mean. What do we get? How do we get mean? Nathan?
The average X and then the Greek.
So it was the Greek E with the X. But what did that Greek E, the sigma with the X mean? What are we going to do? Sum all of the sum all of the values
And then divide.
and then divide by how many numbers there were, right? The sample size. Okay. So we spent a lot of time on that yesterday. We're going to get to the actual focus on the graphs today, which is more interactive. It's more of you doing stuff instead of me just teaching. This is a very straightforward thing. One way, so I want you to notice, was it easy to notice patterns in a table? I mean, we found some patterns, but did we get the full story just from the table? No. That's why in data analysis, we oftentimes create graphs. One of the most common graphs, especially when it's small data like this, is known as a dot plot. Any guesses what you're going to put on a dot plot? A dot? Can anyone see an example of a dot plot around this room? This is exactly what a dot plot looks like. Okay? I was doing this in my Algebra 2 class. They're looking at it from a different perspective than y'all, but I had them do that to figure out some other details. I also have one back here that I've done in a different class in the past. Okay? So literally you're just going to put a dot. right? Now, excuse me, I need y'all to pay attention to this. Because there's two things you need to be aware of with the dot plot. First off, what's missing on this number line right now? The numbers, right? What number do you think we should start with? Maybe 1. I'd probably just go with 0. Let's see if it works. What number do we need by the end? 22. We need 22. So please hear me very clearly on this. A lot of students just start jumping in and putting numbers down without thinking through it first. What I would do before I draw or write another number is I would count it out to see if it works. So if I go by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so that is only 21. So should I start at 0?
No.
What should I start at?
5.
Let's try starting at 1. Right? I was only 1 off. So now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Now I have enough marks. Notice it's going to be way easier to just count it instead of writing it all the way out, having to erase it, and then redo it. So take the time to count it out first. So number your number lines. You don't have, so you didn't get this the other day? So go ahead and number your number lines while I print or find a copy of this for Thomas. Who else? Jordan? You don't have one of these either?
I need one.
Here's one.
Squad. I don't even know, bro.
Hey Thomas, are you want to talking all the way across my room? You trying to talk all the way across my room? Yes, stop.
I can't.
Oh, Jordan, I'm about to print it out. Just wait a second. No, like wait right here. I'll get it to you in just a second.
Okay.
Does it say M? What does it say on the bottom? Is there M4-? Hey, Joey. It's okay.
So on one I put 11 dots. One dot each 11.
Can you set those up?
Wow.
There's one. Put one dot for one.
I need to say something very clearly. The next time y'all laugh at that, every single one of you laughs is getting written up. Point blank period. We don't disrespect students in my class. Don't sit there and laugh. Y'all know better. If you're struggling with something, you don't want someone laughing at you. So don't you dare do that to someone else in my class. All right. It's printed. printing, just wait a second. Yeah, it's printing. Okay, while those copies are being printed for those students, again, we should have already numbered our number line. Some of us haven't even done that. Okay, so number your number line, and from there, so I need you to pay attention to this detail. So how many number ones do I have? One of them. Once I identify that, I'm going to put a dot above the number line. Don't put it on the number line. Put the dot above the number line, just like those dots are over there. Now, when I look, and you need to do all these different numbers, look at the number 4 though. How many of those do I have?
3.
I have 3 of them. So how many dots do I need to put? 3. And I'm going to stack them on top of each other. So 1, 2, and 3. Create your dot plot. Once you have finished creating your dot plot for all 20 values, talk with your group about answering number 3. Jade, I'm going to start lecturing in this class because of you. Get to work on actually talking about this math. It ain't that funny. I know if you're giggling like that, you're not trying to learn math. How did you get 3 dots on one? How many ones do you see? Thank you. Listen, guys, if this wasn't already clear, what you're doing is you're creating a dot plot for the amount of lead in the water. So every time you see a number show up, right, not the site number, the amount of lead in the water, you put a dot for each one of those. That's why you mark it off. If you want, you can just start at the top. There's an 11. So I'm going to go to number 11. I'm going to put 1 dot there. Okay, there's a 22. I know that's here. I'm going to put 1 dot at 22. What are your questions before I start coming around to groups? All right, I need y'all to focus and help each other complete this dot plot. Jordan, can you grab some?
I need to ask you something. I need to ask you something.
That's not even a dot.
So 22 now.
But all that this is the X bar, that's the sample number. Sample means, so sample means. N is your sample size. So you've done averages, right? So you add up all the all of these. That's what this means. It means to sum them. Then you divide by however many. That's just a simple notation. We'll talk about that.
I mean, it's before we
Help you at least get
That's what it's like. Well, that's
So like, I would want to do this. You take this to the left. Hey, Anaya, what group are you in? I don't care. Ignore her.
But I'm already done.
Have you talked with your group at all?
Crossed it off.
Okay. Okay, but you know that you're supposed to now be answering question 3, right? Hey guys, if you finish question 2, I already said this, start working on question 3 with your group. Chill for a second. And also, don't be disrespectful to my class.
You got it.
It's time for you to learn something. First off, it's a deal called Dotplots. Second off, what we're about to do with this is question 3 where it says, hey, what conclusions can you draw? You may not be creating graphs every day, but you will see data graphs around you. Literally, this is an example that's drawn from the real world. So don't sit here and be like, when am I ever going to use this? It's literally about the real world. So stop being a punk, try to do some learning. Let's do some learning. You're capable of walking. That's why you tell me I'm capable when you walk in. Do what you're capable of. Sir. Say again. No. When you say what conclusions can you draw, what does this tell you? What do you learn by looking at that data?
That there's an outlier.
Okay, so there might be an outlier, so talk about this as a group.
Are you serious?
You know what that is?
I was doing the curve up there to show something.
On a coordinate grid, here, plot stuff on the lines, there's usually one that's just out of the way, plus they're not. So, maybe an outlier is nowhere
Thank you. So, hopefully we are all done creating our dot plots. Can someone who's already started on number 3 explain what this question is asking? Yes, ma'am, Jamie.
What did you observe out of the dot plot?
So, what did you observe based on the dot plot that you created? What's another way to say this? What can you summarize from the dot plot? What do you notice based on the dot plot? Don't forget, what I am always going to say when it comes to data is, what story does the data tell you? Right? We created a dot plot. What story do you learn from the data? So yes, what do you notice, right? What conclusions can you draw? So I'm asking you, you've got to keep in mind that this is a dot plot, and I'll finish mine in a second, but this is a dot plot for the amount of lead in the water at this location, right? Whatever, I don't think they tell us an actual city. Okay, but the water in a city, these are the values. So what do we know? What story is being told by this data? Does that help? Was it Maddie, were you asking? Does that help clarify what that question's asking? So again, keep in mind that these aren't just numbers. There's a story with these numbers. What story are you learning from the data? Okay, so talk about it. We'll come back together in a couple minutes to discuss. I know some of it's already done. See if there's any other story that you can find, because there's at least 3 or 4 things that you could talk about here. Okay?
It just leaves that waiting gap.
So what does that mean 7 is? That's the what? You used the term already. What is that 7?
Hey, none of y'all cashed at me last time I put my cash up there. I'm just letting y'all know. $sign JOZANMOYERS. Cash at me.
Okay, there's more to that story. Right? All, in fact, it's not even those, all the, how many are above that 14? So all but 1 are below 14. But also, remember, it's not just 15, 15, 14. More to it than that, too. When you say 7 is the most dangerous, what do you mean by that? Guys, I want you to talk about this together, because Wesley is writing that 7 is the most dangerous. I think it is the most something, but y'all need to talk about all these a little bit more. Okay? Really quickly, by the way, don't draw the smooth curve over it like that. That was just something I was showing my students in a previous class. A dot plot is just the dots. Okay.
What I noticed was that 14
So there's a big gap between 14 and 21, and that's because, what did you call 22 earlier? Okay. Okay, there are lots of stories here. Let's talk over them. It's not what I want you to do. I'm just asking what story is being told. What do you notice? There's so much that you can say. At least come up with one thing.
This is why I think about what I'm being said.
Thank you. Thank you. Thank you. So we're going to have a quick discussion about the different things that we have noticed. And I will point this out. We should have quite a few things that we can discuss. Sorry, I'm trying to also finish off this dot plot. Anybody, raise your hand to volunteer. What is one thing that your group noticed? Just one thing. All right, Barry Lee, what you got?
It goes in a wave pattern.
It goes in a wave pattern. Okay, so when you say a wave pattern, what do you mean?
The numbers go from like small to large.
Okay, so they go from small to large
Like, and back down.
and then back down. Okay, so let me finish creating this and then we'll see that a little bit more clearly, hopefully.
Don't say that.
Were there 4 sevens?
I know.
Thank you.
I know.
11,
No.
5,
Yes.
and 13. Okay,
I'll-
so we'll come back to the idea of a wave pattern in a second. Jordan, what you got?
22 is an outlier.
Okay, 22 is an outlier. What does that mean?
It's by itself.
Okay, it's by itself. Can we add a little bit more clarity to it? Peggy, what were you going to say?
Wait, 12 is too
It's
then.
away from No, it's not.
Say that one more time, actually.
Jim could have.
And it's not just away from, it's really far from. Jamie, what do you want to add?
It's not involved in the cluster.
So someone's had a little bit of data analysis in previous classes. Notice how there's a grouping here? We would say that those numbers are clustered together, and this one's pretty far away. Now I want to pause and I do want to say this. It might be an outlier. There is a mathematical way to determine if it is what we call an outlier in statistics. So that is a great thing to note here. 22 might be an outlier. One of the things that we do, that we will do within either this lesson or the next lesson, is talk about, I think it is this lesson, but we're going to talk specifically about how do I determine if it's an outlier. It looks like it might be an outlier. It is far away from the data, right? Or the rest of the data. But we're going to determine that later. So if I were you, maybe off to the side, I'd make a quick note about what we mean by an outlier, or in general what we mean by an outlier. So outliers are far from
The majority
of the data. But again, we're going to properly define what it means to be far away within these lessons, okay? So in general, if you ever hear someone say outliers, hey, that data point is far from the majority, okay? Peyton, were you raising your hand? Okay. What's another part of the story that we see? Something that you discussed in your groups. I saw multiple other things written down. Ethan.
4 and 7 are the most common numbers.
Okay, let's get a little bit more specific than that. Because I don't want 2 numbers that are the most common. I want just one, which is what?
7.
And what would we call that 7? Not the median.
The mode.
The mode. The mode. Lead concentration. I want you to notice, right, and I should have put context here, but I'm putting context with this. The mode lead concentration is 7 ppb, parts per billion. The mode lead concentration is 7 parts per billion. That's a part of the story. And that's important because that means that the most common, I just realized why y'all put 15. Hold on to that 15, it's important. The most common lead concentration is 7 parts per billion. Why is that important for the context of the study? It's not an average though.
It's the most common number.
It is the most common number, but think about the context. Why do we care about these lead concentrations? Because they can be harmful. What level makes it harmful?
The lethal level.
The lethal level, but if you look here, it says it needs to be below 15 parts per billion. I realize that's why y'all were talking about 15, wasn't it? Gotcha. Yes. Hold on to that. Never mind. The mode lead concentration is 7 parts per billion. That's important because that means that the most common lead concentration is well below that limit, right? Okay, what other story can we see here? So what was the story y'all saw that I told you to change and was the correct one that I just wasn't thinking right? What was the story y'all saw? Now, it wasn't just most of the sites. That I will stand by. Most of the sites are what? Okay, so most sites have a lead concentration under 15. And I will agree that 15 is important because, again, that was the limit, right? But not just most of the sites. All but how many were below 15? All but one, the 22, right? So all but one. Site had lead levels below the lethal, right? Had lead levels below 15 parts per billion. That's a part of the story.
Oh wait, all but one. Okay.
All but one had lead levels below the 15 parts per billion. Yeah. Okay. So we're starting to get into this a little bit. We got some more ideas in there. But let me ask you this. There's two things I want us to think about before we continue. What do you think a typical lead level concentration would be?
2.
Why do you say 7, Marlon? Because what? There's 4 dots on 7? Okay. Anaya, why were you thinking 2?
I don't know.
You just said a number? I will point this out. Do we have any sites with a lead concentration of 2?
No.
Yeah, no, yeah,
We have
Oh.
2 of them.
yes.
I got 1.
I only had 1. I didn't have any at 2.
Wait, I don't got none.
Me either.
Right? Did you have any dots at 2?
No.
No. Okay. Let's continue to think about it. Hey, let me ask you this. What do you think is a mathematical term for what is expected or what is typical for the data? We actually spent probably 30 to 40 minutes talking about the 2 yesterday. Say it louder. The median. And what was the other one? Mean. What was the mean for this data set? We wrote it on a separate sheet of paper yesterday. 7.85. Ah. So I will say, you can't see the mean from dot plots like this, but we did calculate it. But I will point this out. Remember earlier, I think it was Lillian yesterday who said, man, doing the median's a pain in the butt. Y'all remember that? Because you have to like take out the bottom one, take out the top one, keep going, stuff like that. But I told y'all the median separates the bottom
50% from the top 50%.
There you go, bottom 50% from the top 50%. So if I have 20 data points, what should be in the bottom half?
10.
10.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is. The median is right in between those 2 dots. But dot plot makes it really easy to identify the median. And it lets you see other aspects as well. See how much easier that is than having to write all the numbers out? So a dot plot makes it easy to find the median. The median, right, lead concentration is 7 parts per billion. Okay? And so we talked about a lot of things, but the one thing I do also want to point out, actually I want to hold off on that. Those are the main things I wanted you to see. No, so 22 might be an outlier. The mode, right, and the median is 7 parts per billion. We're going to go into quite a few different aspects of data analysis, and we'll go into this more in a second. But what I want you to be aware of is, and I know because someone's just going to giggle because we find it hysterical, there's an acronym to help us remember the 4 things that you need to pay attention to when it comes to analyzing data. The acronym is C.U.S.S. Good, I'm proud of you. Oh, Jamie's in a snicker in the back, got it. Cuss, if you're going to analyze data, what you're going to do is you're going to cuss the data, meaning you're going to look at the center of the data. What are the measurements for centers of data? We already talked about them. The measures for the center. Mean, median, and mode. Thank you. So if we're going to analyze the data, let me actually find the best place to make this note. Okay, really quickly, go to, what is that, M4-7, underneath key terms. M4-7, underneath key terms. Write out this acronym to be able to use this moving forward. So you want to analyze data, or analyze, we already talked about this, I know we did, because we talked about it on the lesson 1. Not this acronym, but we talked about mean, oh, we only talked about mean, median, and mode, didn't we? M4-7, it looks just like this. And again, I don't know if I printed this out for you, Marlon. I didn't. Yeah, it's right there. Yeah. Okay, Jane, you got to this page. You wrote down this acronym. Okay. So when you are analyzing numerical data, you're going to cuss the data. So you're going to look at the center, the mean, median, and mode. You're going to look at unusual aspects. Does anyone know of an unusual aspect that we already talked about?
Outlier.
The outlier. The outlier is a common unusual aspect. I'm going to leave that set of parentheses open for now because there's one more thing we'll look at. We're going to look at the shape of that graph. And we're going to look at the spread of that graph. We're going to talk about those things more, but be aware that we're going to look at the center, the unusual aspects, the shape, and the spread. That's where the acronym C.U.S.S comes from. Trent, did you write those, the acronym and the words down that you need to know?
Yeah.
Okay. All right. So here we go. We're getting into activity 1.1 now. Now, excuse me. Oh. I know someone's still writing down, but focus on getting that written down. And let's look at this question, right, from activity 1.1. Sorry. Isn't that on those key terms? For now, go to another page. We'll come back to this. I'll give you time right now. You'll need to be on page M4-9, and let's look at this question. Because remember, this is what data analysis is all about. What story is being told? What did this group note, right, about those 20 data points? Most of them, but not even just most of them. All but one site had lead levels below 15 parts per billion, right? So what story is being told? Does that data show that action is required to reduce the amount of lead in the neighborhood? Probably not. There's probably just something weird that happened to that one site.
You shut that site down and you're good.
Say again?
Just shut that site down and you're good.
So maybe just shut down that site, okay? So that's what we want to notice. What story is being told? There probably doesn't need to be any action. Because that was only one site. It's only one site with lead concentration above 15 parts per billion. And so that's what we want to notice, and that's why we don't want to just say most, right? It's not even just most, it's all but one. There's only one site with lead concentration, not about, above. Sorry. Above 15 parts per billion. Right, so there probably doesn't need to be any action because there was only one site with lead concentration above 15 parts per billion. What story is being told here? I already heard one student say, when am I ever going to use this? You will always need data analysis. You will always need to be able to know what story is being told here because data comes from the real world. It's not made up. It's not just a random equation just for the sake of having a random equation. It's telling a story. Well, what is that story? Okay. So what we have already learned is how to create a dot plot. There's another graph. Oh, I'll wait a second for you to finish. Sorry, Ethan, and the others still writing. Jamie,
I really need to use the restroom.
I need you to try to go before class.
I did.
Oh, and still.
Trust me. Yes.
I will also say, if she's saying that she tried before but there was packed, guys and girls, if you come in and you do your bell ringer quickly, I'll let you go use the restroom after the bell rings if you've already done the bell ringer. So I understand that those bathrooms get packed. Come in, do your bell ringer, and then quickly go to the bathroom before we start class. Okay? I know fourth block is a rough time. Yes, sir, Jordan.
Do we gotta show you that we did it, or like, could we just tell you that I did my bell ringer?
You guys show me
Okay.
before you go use the restroom.
Type.
Alright. So, we've already looked at dot plots. Here is a new type of graph, though, and it's called a histogram. And so, what a histogram, remember I mentioned this earlier, a dot plot is good when you have a lot of points or just a few points?
A lot.
Really?
Just
So
a
if I
few.
had 100 points, would you want to do 100 points on a dot plot?
That was an estimate. I meant to say just a little.
No.
Think about it this way, and I hear you, but like, if I had 1,000 points, would you want to graph 1,000 points?
No.
There's no way, absolutely no way that I would want to graph 1,000 points. And so this is where a histogram is really good. So the mayor of Greenville wants to analyze the lead levels for the water in the entire city. And so we have a frequency table here. Notice this is displaying data for the amount of lead in water samples from sites all over Greenville. And so I'm going to talk about a histogram in a second, but I want you to think about this. This is a bin, is what it's called, and it's a bin of 0 parts per billion up to 5 parts per billion for concentration of lead water. So what does this 32 mean? But remember, the concentration was between 0 and 5 parts per billion. So
It is working.
thank you.
You welcome.
705236.
Yes, sir. 705236.
Okay. There you go. So, this is why I'm bringing this up, because I have seen students struggle with this in the past. What I am saying is that there were 32 data points where the concentration was between 0 and 5 parts per billion. This is the frequency, or how many times that happened. Okay? Again, I would write that down if that was not something you saw right away, so that you can use that in the future. The frequency is how many data points fall into that bin. Notice they define a bin right here. It's an interval of data, right? And so what we're saying is there were 32 data points that had between 0 and 5 parts per billion of lead in the water.